longer the magma has to cool, the larger the crystals will be in the rock. So in granite, which is an intrusive rock, which means it forms under the crust of the earth or inside the earth.
An example of extrusive rock would be obsidian, because if you, as you see right here, it hardens underneath the ocean, but it's still on the surface. And also like pumice, which I don't. Okay, we do right here, and a couple other rocks.
And you can notice in extrusive, the grains are smaller, the crystal grains, because it is formed on the outside of the earth. So it'd be when the magma is on the outside. See, if you notice, the grains of crystal are smaller than the larger ones here.
Okay, most people think the first rock on Earth was actually igneous, because it's, of course, volcanoes, and that's how they believe Earth and most of the land was formed. And, Phil, do you have anything? Do you have anything to say?
Yeah, they believe that the igneous rock begins in the mantle, and where it's still molten, and then it can either like form and harden.
In the form of intrusive, or it can rise up to the surface and come out through a volcano or other molten lava forms, and harden on the surface towards extrusive.
And these are examples of obsidian, or different rocks. Obsidian is an extrusive rock. You can see how smooth and shiny it is. So obsidian is this would be a chunk that, say, a scientist would pull out of, it would be a sample of the lava. They take it, carve it out of a place where a volcano has exploded, and that would be the result. Would be the rock. And there are no grains of crystal at all in this specific sample. But as in quartz, which is an intrusive rock, you can see the larger, more they stand out. The crystals really stand out. It almost looks like amethyst.
Okay. And on your handout, I know it's not very clear, but there is a little chart right here. And what it says is, it says that all igneous begins as molten magma, which hardens to form igneous rocks, and then weathering and erosion can turn it back into sediment, which is right there. And then, of course, the sediment can then go through pressure and hardening, which turns it into sedimentary rock. And then heat and pressure turns it back into metamorphic, and then, of course, more heat turns it back into magma. So it's pretty much a cycle of its own.
And this is how it's all created. These are more different visuals to explain the concept. Right here, you would see the magma coming up, and it's being throughout the earth. So down here, you would see the intrusive rocks form, and you can see one of the plates coming down. Here's another one. It's more clear. It shows the entire cycle. It shows metamorphic rock and magma. And when the volcano explodes and the lava comes down, it turns into igneous rock. And like Nathan said, it would turn into sediment through weather erosion or acid erosion. And then it would turn into sedimentary rock as it is packed down throughout time, and more sediment packs it down. And then there's metamorphic rock with the layers, and the cycle goes over again.
Okay, and that's it.
Do we have any questions that weren't clear to anybody? And the handout explains everything that we just went over.
My only question for you is about the crystals again. Which one has the larger crystals, intrusive or extrusive?
Intrusive has larger crystals because it has more time to cool underground. And then the extrusive, which is external on the outside of the Earth's crust, has less time to cool. Yes?
Why would you say it has less time to cool, out of curiosity?
Because instead of being coated with other hot materials, it's out in the open where it's cooler. Or like obsidian, it hardens underneath cold water.
So as soon as it comes out, it cools right away. When it has more time to cool, it cools slowly. The crystals form and become larger. Does that make sense?
Does anybody have any questions? Anything that we missed? Yes.
How many igneous rock types are there?
There's